Okay friends, we are all set for this recording the labs of this course, Theory of Structures, and as you know we are using the book Design of Steel Structures. The name of the author is Nagy, and we are following the edition second. So before we go to the problems on tension member, I would like to remind you that you have to revise the theory and the problems on rivets and the welded joints. This is very much required for following labs or the practicals. So let's start with the first problem on the tension member. We will start with the problem number 4.1. So this problem says we have a flat of size 15 into 1.2 centimeter, and it is connected to the gusset plate, and it is asked to find out how much tension or maximum tension this flat will carry under two cases. So there are case A and case B. Before we go to the case A and B, other inputs given are permissible tensile stress is given as 150 megapascal, and the size of the rivets is given, that is dia is given as 22 millimeter. So let's try to solve this problem and try to find out how much maximum force will be transferred by this tension member under given two conditions. So condition A is this is case of chain riveting, and the diagram or the picture for this will be like this is the flat, and this is the gusset plate to which it is connected, and there are two chains of the rivets. First, this is first chain, and this is second chain. The most what we require, or two important dimensions we require, are the distance between these two lines, or this is called gauge distance. So this is 75 mm, and another distance, that is pitch, and that is 75 mm too. So if you know these two distances, we can find out how much maximum force will be transferred by this kind of joint. Before we solve this problem, there is one thing we need to find out, that is gross dia of rivets. And you know that for this size of rivet it will be 22.1.5, so it will be 23.5 millimeter. Okay, now we are all set to solve this problem for the case A as we drawn earlier. So first of all we need to find out the A net, or the net area available to transfer the force, and the formula for this is T into B minus N into D. Just plug in the values. T is the thickness, so thickness of the plate is 1.2 centimeter, remember that, into B is the width of the flat, that is again in centimeter. The number of rivets are 2, and D diameter is 2.35 centimeter, 2.35 centimeter, or 23.5 millimeter. So just to remind you, in this case the failure will be on this section, or you can take any case out of these three. So the failure will occur on any one of these, or this will be the least area where the failure will occur. So if you consider 1, 2, 3, then you can see there are two rivets, and by this way you can find out the A net, that comes to the 22.36 centimeter square. Now once you know the A net or net area available, you can find the maximum tension. That will be equal to definitely it will be the sigma, that is stress into area, right? So stress is given here 150. Again this is 12.36, that is area. This is in megapascal, which is equivalent to Newton per millimeter square. Remember this millimeter square, and this is in centimeter. So we need to convert this into uh, this figure into millimeter square. So we need to multiply it by 100, and further to convert that, so this total quantity will give us Newton. So to convert this into kilonewton, it will be, again we need to divide it by 1000. So finally answer will be 185.4 in 80.44 kilonewton, right? Okay, this is now case B. Let's draw the figure for this. In case B, it is given like this. So it's staggered rivets. The rivets are arranged like this, and they have given the failures sections. One is like this along 1, 2, 3. Then other is 4, 5, 2, 3. Then another is 4, 5, 2, 6 and 7. So let's take it one by one. So suppose first case is failure of the section along 1, 2, 3. Then we know the formula for this. A net will be equal to T into B minus N into D plus 1 into S square for C. So here just plug in the values. T is already we know 1.2, B is 15, minus N is 1 because failure is along 1, 2, 3, and D is already known, that is 2.35 plus how many staggered rivets are there. So you can see that in case of 1, 2, 3 section there is no staggered rivet, there is just failure on the least area section and there is no staggered rivet. So this particular quantity will become 0 here, and the A net here will be equal to 15.18 centimeter square. Okay, for the section, now consider section 1, 2, 6, 7. For this failure will be like this: 1, 2, 6 and this is 7. So how many staggered pitches are there? This is the only one. We have to take this into consideration while calculating A net for 1, 2, 6, 7 failure. So A net will become almost same, just we have to add the term for the staggered pitches. So it will become 1.2 into 15 minus 2 into 2.35. This is same, plus we have to add there is one staggered rivet, and then S square staggered pitch is 50 millimeter or 5 centimeter square of that, and then 4 constant and G is the gauge distance. In this case it is 3.75. So if we calculate this area will come to 14.36 centimeters square. So this is for the failure along 1267. Next we have to consider the failure along 45267. If we draw this, it will become like this. This is 4, 5, 2, then 6, then 7. So it start with like this: 4, 5, 2, 6, 7. So again we have to find out the A net. So rest of the terms will be the same, only we have to add for the two staggered, which is this one and this one. So it will become 2 into 5 square same, that is the staggered pitch, and the denominator quantity is 4 into 3.75. So if we calculate this A net, it will become 13.54 centimeter square. Okay, as we have seen for case B, and we have seen the failures along 1, 2, 3, then 1, 2, 6, 7, and 4, 5, 2, 6, 7. So for all these three possible edit for the failure of the joint, we have to find out the least A net. So for this case, A net was 15.18. For this case, A net was 14.36, and for the last case, A net was 13.54. Obviously, least we have to consider the minimum A net or the least A net to calculate the maximum tensile strength, maximum tension transferred by the joint or the tension member will be equal to A net into sigma 80, that is permissible stress. Here we have to consider the minimum value of the A net. So again it will be same 150. This is to convert into kilometer, and the least area is 13.54, and this 100 is to convert into this centimeter square quantity into millimeter square. So finally we can get for case B, maximum tension transferred by this joint will be 203 kilonewton. That's it for this problem. Thank you.